I want to talk about series and parallel resistors and the concept of an equivalent resistor. Here I've drawn two series resistors, R1 in series with R2, and I have a battery with a voltage V that applies a voltage across R1 and R2. And on the right I have an equivalent circuit. It has the same voltage V and it has the same current flowing in the circuit I. And I want to calculate the equivalent resistor to R1 and R2. I want to find one resistor that I can use to replace two resistors. And the answer is R, the equivalent resistance, is equal to the sum of the two resistors, R1 plus R2. Let's see if we can prove this by using Ohm's law. We know that the equivalent resistance by Ohm's law is the voltage divided by the current. The voltage across the resistor divided by the current through the resistor. Now on the circuit on the left side, the key concept here is the same current flows through R1 and R2. So I can calculate the voltage across R1. So V1 is equal to the current times the resistor R1 by Ohm's law. Now I can calculate the voltage drop across R2, and then we'll call that V2 is equal to the same current I times R2. So the total voltage, if we have 0 volts here and we have voltage V here, the total voltage V is equal to the sum of V1 and V2, which is IR1 plus IR2. Now on the right side, we said the equivalent Req is equal to V over I. So if that's true, let's write that R equivalent is equal to V over I. And I can substitute this expression for voltage from the left side, and I can get this. IR1 plus IR2 divided by I. And lo and behold, the i's cancel, and I'm left with R equivalent is equal to R1 plus R2. So we've used Ohm's law, and we show that the equivalent series resistance is just the sum of the resistors. So in a series circuit, the equivalent resistor will always be bigger. It'll be bigger than any of the resistors in the series circuit. Let's erase this. Now let's consider two resistors in parallel. The circuit on the left has resistor R2 in parallel with the resistor R1. The circuit at the right is exactly the same, except it has one equivalent resistor that is equivalent to the parallel combination of R1 and R2, and that we call Req. And we know from Ohm's law that Req is the voltage across the resistor divided by the current through the resistor. The circuit at the left has a branch in the current. The current flowing from the battery is divided between R1 and R2. And we can calculate the current in R1 and R2 and add them together and get the current I. So the current I is equal to the current flowing in the R1 branch, which is the voltage across R1 divided by R1, plus the other current flowing in R2, which is the voltage across R2 divided by R2. And we can substitute this expression into this equation here, and we can solve for Req. So let's do that. Req is equal to the voltage divided by this current, which is V over R1 plus V over R2. Now notice that the voltages cancel, and I'm left with 1 divided by 1 over R1 plus 1 over R2. Let's simplify this expression a little bit. Let's multiply the numerator and the denominator by R1 times R2. So we'll multiply R1 times R2 times the denominator. And when we do this, we get R1 times R2 divided by, and here, let's see, the R1 is going to cancel. We get R2 plus R1. So we find that the equivalent resistor is just the product of the two resistors divided by the sum of the resistors. So it's this expression right here. And so whenever you have resistors in parallel, the equivalent resistor is always smaller than any of the resistors in the parallel circuit. Let's do a sample problem involving series and parallel resistors. The circuit at the left has 200 ohm resistors that are in parallel, and they're in series with another 100 ohm resistor. And we want to find Req, which is the equivalent resistor that would replace these three 100 ohm resistors. So to do that, let's first find the equivalent resistance of this parallel combination. And we know from previous that the equivalent resistance is a product over the sum of these resistors. So it's 100 ohms times 100 ohms divided by the sum, which is 200 ohms, and that is equal to 50 ohms. So we can substitute 50 ohms for these two 100 ohms, and when we do that, we get 100 ohms in series with a single 50 ohm resistor. And we know from previous that resistors in series add, so the equivalent resistor of this network, or Req, is equal to the sum, which is B1 50 ohms. Let's do another sample problem. Let's say we have three resistors in parallel. And to make the math simple, let's say this is 60 ohms, this is 60 ohms, and this is 30 ohms. Before we came up with an equation for the equivalent parallel resistor when we had two resistors, but now we have three resistors. So what do? Well, let's replace the 60 ohm resistors with an equivalent parallel resistor. So we know that the parallel resistor is a product over the sum, or in this case we can just by inspection, if the resistors are the same, if the parallel resistors are the same, the math always works out that the value becomes half. So the 60 ohms in parallel becomes 30 ohms in parallel with another 30 ohms. And again, we can do the product over the sum, or we can just look at it. Whenever we have equal values in parallel, the value cuts in half. So the equivalent resistance in this case is 15 ohms.